right, hello. So at this point, you've been introduced to the concept of stoichiometry, which takes the idea of mole conversions and combines them with balanced chemical equations. So I'm going to review some of that with you as far as how to use a balanced chemical equation to come up with what are called mole ratios. Okay, so if you'll recall that the coefficient is the number written that comes before the formula, and it tells you how many of each of these units are present. And when there's not a number present, that means there's just one. So we can say there's one formula unit here. We can say that there are 3 carbon monoxide molecules. We can say there are 2 iron atoms. We can say there are 3 carbon dioxide molecules. These also refer to the total number of moles present. So I know there's 1 mole of iron 3 oxide. I know there are 3 moles of carbon monoxide, 2 moles of iron, and 3 moles of carbon dioxide. So we can use these to make ratios. This is 1 to 3, 1 to 2, and 1 to 3, 3 to 2, 3 to 3, and we can use them in any format that we need to, depending on when we're trying to find, what's the mass reacted compared to the mass produced, or formula units reacted to the molecules produced. So there's a relationship that allows us to convert between 2 different substances. So we could say that we have 3 moles of carbon monoxide for every 2 moles of iron. And likewise, if we're needing to convert from carbon monoxide to iron, we can also write it the other way. So it just becomes this extra tool that allows us to convert between different things going through a mole. So don't forget that the other type of conversion factors are the atomic weight in grams, and of course, Avogadro's number, where particles can be anything like atoms, ions, molecules, and formula units. Okay. So this just becomes another way for us to convert between 2 different things as opposed to like just one thing, whether it's an element or a compound. Okay, so let's try practicing some of this. So we have this reaction of hydrogen reacting with oxygen to produce water. So the first step is you always need a balanced chemical equation. Don't forget, hydrogen is a diatomic, oxygen is diatomic, and it produces water. So I need 2 oxygens and 4 hydrogens, and we now have a balanced chemical equation. So I can see that we have 2 moles to 1 mole, 2 moles to 2 moles, or 1 to 1, okay, and 1 mole to 2 moles. All right, let's start off with this first one, which is pretty easy because we're given grams of water and we're trying to find mass of hydrogen. Okay, so we're given grams of water and we want to find the mass of hydrogen. Well, the fact that it says mass of this and mass of that, I know I'm going to need the molar mass of each of those. And I'm also going to need the mole-to-mole ratio of hydrogen to water, which is 1 to 1. So I'm going to start off with my given. And just like we did before, I know I can convert mass to moles of a compound by dividing by the molar mass. So this is not new. We've done this before. Okay, that's great. Gives me moles of water, but the question says give me mass of hydrogen. So I know I'm not done yet. Now I need to convert moles of water to moles of hydrogen, because remember, you can convert anything to a mole or anything from a mole. So the mole becomes the center point. So I'm going to have to use the mole-to-mole ratio of hydrogen to water. Since I need moles of water to cancel, I know that needs to go on the bottom. And I want to convert to moles of hydrogen. Well, that's fine and dandy. Now I'm left with moles of hydrogen, but the question's still asking for mass of hydrogen. So since it's asking for mass, I know I'm going to need to use the molar mass. And we've done this step before too, where we just convert moles to mass by multiplying times the molar mass. And this becomes 150 divided by 18 because, oops, sorry, I wasn't paying attention. It's a 2. You were absolutely correct on catching that. I appreciate that. So this is 1, that's 1, and that's 1. So it's just 150 times 2.02 divided by 18. Using correct significant figures, this was 4. I ended up with 16.83 grams of hydrogen. All right, so that's one way to use a mole-to-mole ratio in the case of using the molar mass of both the two things that we're converting between. Okay, so this is a step you've done before. This is a step you've done before. The only difference is converting moles of one thing to moles of another. All right, the question is how many molecules of water given moles of oxygen? Well, I know since I'm finding things, I'm going to need Avogadro's number. And since I know I'm converting moles of one thing to moles of the other, I'm going to need the mole-to-mole ratio. And that's all I need. So start off with the given. I need to convert moles of oxygen to moles of water. So I know I'm going to need to divide by moles of oxygen and multiply by moles of water. And that gives me moles of water, but the question says molecules, and I know to go from moles to things, I multiply by Avogadro's. And using correct significant figures, we end up with this many molecules of water. So this is 8.25 times 2 times Avogadro's. Because these are just ones. You can even make that 1. Okay. All right. All right, how many moles of oxygen react with moles of hydrogen? Well, the only thing I need is the mole-to-mole ratio, and I see that's 2 to 1. You can even set this up as a proportion and solve it like a proportion. So that becomes 8.45 divided by 2, using correct number of significant figures and rounding, we end up with 4.23 moles of oxygen. Okay. What mass of water was produced given many moles of hydrogen? Well, I'm going to need the mole-to-mole ratio. So I know that there are 2 moles of hydrogen for every 2 moles of water. And I know that 1 mole of water is equal to 18 grams of water. Start off with the given. I need to convert moles of hydrogen to moles of water, so I'm going to need to put moles of hydrogen on the bottom. And I need to convert moles to mass of water. So converting moles to mass, you multiply. And using correct significant figures, we end up with 176 grams of water, which ends up being, since the density of water is 1 gram per milliliter, that it actually ends up being 176 milliliters of water. Pretty cool, huh? Because the density of water is 1 gram per milliliter. Neato, huh? So you can take mass times density and you get volume. That's for later. Okay? And that's how you do a variety of those kinds of problems. There's many more that we could also solve in all of this. We could talk in terms of volumes of the gas of oxygen and hydrogen using Avogadro's law of 1 mole for 22.4 liters, but we'll save that for later when we cover gases. So there are many, many different types of problems you can do just besides these 4. So I don't want you to think these are the only 4 types you would see. You just need to know how to use those 3 different kinds of conversion factors when you solve problems. So you just need to learn mole to mole ratio, mole of A, mole of B, where A is any kind of compound and B is any kind of compound, and the number is the coefficient given in the balanced equation. So these are the 3 types of tools now. We're going to keep adding to our list of tools as we continue to move through the course on solving chemistry problems. Okay? See you later.